Okay, welcome back. So what we're going to do now is talk about additive color mixing. We talked about subtractive color mixing that's used by dyes and pigments in the previous video. Well, colors can also be mixed by light sources. So in other words, you're sending lights of different color and you're mixing them. And that mixed light is coming to your eye. It can come directly to your eye, or it could be reflected off of some reflecting surface and come to your eye. Okay, so again, we're not sending white light and then relying on absorption to remove certain colors from the light and then sending that light to your eye. We're actually sending different colors directly to your eye from different light sources, or one source that's sending different colors. Okay, so this is going to be used on things like TVs, projectors, monitors. The computer screen that you're looking at right now, there are different colored pixels on your screen that are sending different colors to your eye, and those colors are being mixed, and you're perceiving different colors on the screen. Okay, now, just like with subtractive color mixing, we can make a simple color triangle, and the difference, though, now, the primary colors are red, green, and blue. So red, green, and blue. If you recall, for subtractive mixing, they were red, yellow, and green. Red, green, and yellow. Now they're going to be red, green, and blue. Okay, so what happens if we mix these primary colors? Okay, the RGB. Well, if you mix red and green, you will in fact get yellow. And that's probably the most surprising one, that red and green are going to be perceived as yellow. Now, the shade of yellow, that's going to depend on the amount of red and green, and also, but red and green, pure primary, are going to give you a pure secondary of yellow. Okay, red and blue are going to be perceived as magenta, and blue and green are going to be perceived as cyan. Those are the secondary colors. Now, what happens if you mix all three primary colors, red, green, and blue? You will get white. Okay, so red, green, and blue, you'll get white. So now the shade of white is going to depend on the amount of the primaries that you're mixing, okay? But you're going to get white with red, green, and blue. Okay, now I want to show you a demonstration where I'm going to take a red laser and a green laser. So I'm just going to send two laser beams onto the whiteboard, and I'm going to then overlap them. So we're going to mix red and green, and I think you'll see that we get yellow in the video. But let me go ahead and run that. So I'll call up this other PowerPoint. Okay, so before I even start the video, you can see that I have a red laser spot over here and then a green laser spot over here. Okay, so let me go ahead and run the video. And you can see, as I overlap, you see that yellow? Again, I'll do it again. Let me pause it. Right there, right where the red and green are overlapping, you see that yellow. Now, if you recall, when we talked about the spectral response, the so-called spectral response of your eye, you perceive yellow-green. That's the peak of the spectral response. So it turns out that this green laser is actually delivering less power, less energy per time than this red laser. But we're actually perceiving the green to be brighter, okay? Well, if you saw this in real time, the green will actually appear much brighter than the red, okay? And I'll show you this in person too, but I just wanted to point that out. But when there's this overlap, you see this yellow. Okay, and you can see it right there. Right now, you can sort of see that yellow. So it's true. Red and green together will give you yellow. So it's really cool because again, I think that's a little bit unexpected. I guess I'll run it one more time. There you go. Look at that. Okay. Okay. We'll end that. Now, I did want to also show you though, and you guys may have noticed this when you're changing the color of fonts or colors if you're making a PowerPoint presentation, that little pop-up window that you get where you can choose custom colors, you're basically doing additive mixing right there. Okay, so I'll show you. Let me just see if there's anything else I want to mention before we do that. I don't think so. Nope. Okay, so in fact, what I can do is probably the easiest thing is if I just highlight this and I go, you can't see right now because there we go. I'm going to home, right? And see right here, I'm going to just choose to change the font color and I'm going to go more colors. Okay, so now you can choose colors from this pattern right here. But if you go to custom, let me see if I can make that a little bit bigger. There you go. And I mean, this you can do the same thing in Word, right? Or any application where you change colors of fonts or draw things, lines and so forth, shapes. This color model, it's known as the RGB model. And you can adjust the number here. And the standard way this is done is this number will range for each of the primaries from 0 up into, I should say, 255. So you can see the maximum number that I'm going to be able to get is 255. So there are 256 color settings for each of the primaries. And by choosing different numbers, right, you can get different shades. And this gives you what's called the hex code, which is another way to refer to a certain color mixture of primaries. And if you do any, like certain computer programmers, they'll specify colors by the hex code. But what I wanted to do, and the color that you get, it shows up on this. I don't know if you can see here. Let me lower this. Okay. Okay, so you can choose a color here, right? And you can just choose any color you want, and it'll tell you the relative mixture of the RGB. You'll also see that the shade right here in this window. So what I'm going to do is I'm going to take a pure red. So I'm going to make this 255. Okay, and the green I'm going to make 255, and I'm going to turn the blue down to 0. So what I'm mixing now are pure primaries of red and green, and you can see that what I'm getting is this yellow. Okay, you also can see on this little strip where it's pointing right there. Okay, now if I take a pure red at 255, and I'm going to put no green, and I'm going to put in pure blue at 255, then I get the magenta. You can see right there. Okay. And similarly, I can turn off the red and put in 255 here. So now I'll mix the primary green and the primary blue, and I'm going to get this cyan. Okay, so, and you can play around with this and change the level of the primary, or if you will, the amount of the primary, I guess you could call it, and you can create different shades. Oh, another thing I can show you is if I put red at 255, so now I'm mixing red, green, and blue. The pure primaries, you can see what I'm getting here. So I'm getting this pure white. Okay. All right, so it's something you can play around with, the additive mixing tool, when you go to make custom colors, when you're changing the font color or the color of an object. So I thought I'd just point that out. Okay, that's it for this video. In the next video, the last video for part 3.5, we're going to talk a little bit more about vision, and also because we're talking about aberrations. So we'll talk about cornea, astigmatism, and then also talk about other aberrations that can affect a lens. Anyway, I'm not describing that very well. Just wait for the video. Okay, goodbye.